Solving inequality word problems. The owner of Fred's Fish Market orders cod and salmon. He wants to buy at least 50 pounds of fish, but cannot spend more than $300. Cod is $4 per pound, and salmon is $7 per pound. So we need to solve this problem. To solve this problem, we're going to need to graph inequalities. We're going to need to set up inequality statements for this problem. So first we're going to need some variables. We're going to need x, and we'll call x the pounds of cod that Fred is buying for his fish market. Pounds of cod. And y will be the pounds of salmon. So, the owner wants to buy at least 50 pounds of fish, but cannot spend more than $300. So we're going to talk about first the at least 50 pounds of fish. So if x is the pounds of cod and y is the pounds of salmon, if we add those two together, we will have the total pounds that the owner buys. And he wants to buy at least 50 pounds of fish. If it's going to be at least 50 pounds, that means that it needs to be bigger than 50. So we're going to have greater than or equal to 50. Our next part of the problem, he cannot spend more than $300. Cannot spend more than $300. So we're going to have a problem, an inequality that includes 300. And we know that cod is $4 per pound and salmon is $7 per pound. So x represents the pounds of cod. So if we take the amount per pound of cod, which is $4, and multiply it by the pounds of cod, we will have how much it will cost for the cod. 4 times x. And then we need to add and figure out how much the salmon is. The salmon is $7 per pound, and we know that y represents the pounds of salmon. So we're going to add 7y. The owner can't spend more than $300. That means whatever he spends on the fish, needs to be less than 300. So less than or equal to 300, because he can't spend more than $300. And these will be our two inequalities. With these inequalities, we're going to need to graph them onto our graph that is on the far right side of your paper. You need to solve these equations for y. So in our first one, in our green one, we're going to subtract x from both sides. We'll have y greater than or equal to negative x plus 50. This equation is in slope-intercept form. If we imagine that this is the equal sign in here, and we can graph this like we've graphed other lines. So we have our intercept, which is 50, and our slope, -1. So our intercept 50 goes on our y-axis on our graph, and our slope would be going down 1 and to the right 1. And our slope, and the next point would be there. And we can graph a line through those points that covers our whole graph. Next, we will need to shade, because this is an inequality. Y greater than or equal to means that we're going to be shading above the line. So we're going to shade above this line. And that will be above the line. Now we need to graph the second equation. We need to get y by itself. So we're going to subtract 4x from both sides. you have 7y less than or equal to negative 4x plus 300. Divide everything by 7. We will have y less than or equal to negative 4 over 7x plus 42.8. So again, this equation is in slope-intercept form. We have our intercept, 42.8, and our slope, negative 4.7. Graph this. 42.8 is about here. It is between 40 and 50, and is closer to 40 because it is less than 45. And then our slope is negative 4 over 7. So we're going to go down 4. 1, 2, 3, 4. And it's always a little bit above the line. And then we're going to go to the right 7. 1, 2, 3, 4, 5, 6, 7. And that will be our other point to graph. We draw a line between these points to graph our inequality. And then we will need to shade. When we shade this, we're looking at the inequality. It says y less than or equal to. When we have less than or equal to, we're going to be shading below the line. So below the blue line is where our shading will happen. Our solution for this problem will be where the shading crosses each other. So if you look, we have this section right here where both the green and the blue shading crossed. And any point that is inside this section would be our answer. Would be a solution for the owner to figure out what to buy so that he is not spending more than $300 and he's buying at least 50 pounds of fish. So on your paper you should have this graph and you should have the work on your paper. You gotta have your variables. You need to have your variables and you need to have the equations that you are graphing along with what you set up to solve the problem. Okay, take a moment to finish that and you will be going on to the second problem. If you can start that on your own now. The second problem. Mr. Bloom is designing a rectangular flower garden with a fence around it. He can use no more than 80 feet of fencing. He wants the width to be at least 5 feet and the length to be at least 20 feet. So first we're going to talk about what rectangular is as a refresher. So rectangular, if you remember, we have both of these sides, the opposite sides, are equal to each other. So this will be the width. So we're going to have 2 widths and we're going to have 2 lengths. Or there are 2 lengths in the rectangle. So we're going to need 2 variables for this problem as well. We're going to need to use x and y because our graph is using x and y, so we want to use the same variables that the graph is using. So let's let x represent the width of our rectangular flower garden and y equal the length of the flower garden. So we can use the first piece of information about not using more than 80 feet. No more than 80 feet. So the perimeter is what would be used. So the total distance around the rectangular flower garden would be 2 times the width, which is x, So 2x plus our other two sides, which are our lengths. And our length is the variable y, so it's going to be plus 2y. And it can't be more than 80 feet. So we have 80, and the inequality we're going to have this number, whatever 2x plus 2y is, it needs to be less than 80 because we can't have more than 80 feet of fencing. So that means we're going to have less than or equal to 80. That's one of our equations. Our next piece of information that we're going to need to figure out or use is that the width needs to be at least 5 feet. The width to be at least 5 feet. Our width is x, so we're going to use x. And it needs to be at least 5 feet. So the inequality we're going to have, if we think about it, the number x, whatever the width is going to be, if it needs to be at least 5 feet, it needs to be bigger than 5. So like 6 could be a possible width. So that means this number is greater than this number. So we're going to have x greater than or equal to 5 because it needs to be at least 5 feet. We're going to do the same thing with the length to be at least 20 feet. If the length is to be at least 20 feet, length is our y. We're going to have y and 20. And since it needs to be at least 20 feet, which is very similar to what our width wanted to be, is going to be y greater than or equal to 20. All right, and then we're going to need to graph these three equations that we have. So the first one, the blue one, we have, or the black one, sorry, we have 2x plus 2y less than or equal to 80. We first need to solve for y so that we can graph this and get it in slope-intercept form. So subtract 2x from both sides. You have 2y less than or equal to negative 2x plus 80. Divide both sides by 2. Y less than or equal to negative 1x plus 40. Now we need to graph this equation onto the graph. On your paper is on the far left side, or sorry, far right side. So 40, this is in slope-intercept form. 40 is our intercept. So we're going to go on to our graph and graph at 40. And our slope is negative 1. So we're going to go down 1 and to the right 1. That will give us another point. Then we draw a line through those points. All right, and then from there, since this was also an inequality, we're going to need to shade. We have y less than or equal to. When y is less than or equal to, we're going to be shading below the line. So below the line. Okay. And then we need to go to our second inequality that we have, x greater than or equal to 5. When we have an equation that's x equals, this line is always vertical. Vertical line. That means up and down. So x greater than or equal to 5, that line is going to be, right here's 5, so it's going to go up and down through that point. So right here. That is going to be the line. But we still need to graph the inequality part. We have x greater than or equal to 5. If x needs to be greater than or equal to 5, it would be above, but since there's no above, think of it as like a number line. If we have 5 is here, which side will be bigger than 5? Will it be this side or will it be this side? It will be the right side. So we're going to shade everything on the right of the green line. Lastly, we need to graph the last inequality, y greater than or equal to 20. So for this one, it's going to be a horizontal line. Horizontal line going left and right. So at 20 on our graph here, we're going to have a point and the line is going to go left and right. So graph point at 20, and then you're going to have the point going left and right. And then we're going to shade. Where do we shade? We have our inequalities y greater than or equal to 20. When it's greater than or equal to, we are shading above the line. So in this problem, we're going to shade above this blue line, so it'll be everything up here. So we're going to shade above that blue line. And then our answer is going to be where the black, the blue, and the green lines cross each other. And if you can see, it is a triangle region that is in the middle of our screen, in the middle of the graph. So right in this piece right here would be where all the answers for what kind of garden Mr. Bloom can have that meets all of his requirements. So in here would be your answer for this problem. All right? Take a moment and make sure that you have all the same information on your paper and your graph is complete. I will be checking this paper tomorrow when I return. So make sure you have this. If you finish going over this and you have this all on your paper, go on to the next problem and start that before I start the next problem. All right. On to the last problem. Tickets for the spring dance cost $3 per person or $5 per couple. To cover expenses, at least $750 worth of tickets must be sold. However, no more than 400 people can fit in the gym where the dance is being held. So again, we need to set up some variables to use to solve the problem. Our first variable, we're going to need x. X will represent the single people. And then we're going to need our other variable, y. And that will represent our couples. Couples are two people. So we can write an equation about the cost per person, which is $3 per person or $5 per couple. And we need to sell at least $750 worth of tickets so that we are covering the expenses. So it's going to be $3 per person, so $3 per single person, X, plus $5 per couple, plus $5 per couple, Y. And we need to sell at least $750 worth of tickets. So we know there's going to be some relation with 750. And if we need to sell at least $750 worth of tickets, 750 needs, what we sell needs to be greater than or equal to 750 to cover our expenses. And that covers the first part. But no more than 400 people can fit in the gym. So we need to write an equation for how many people can be in the gym. So we know that x will represent how many of the single people will be there, but y represents couples, and couples are 2 people. So it's going to be x plus 2y, and there is going to be 400 people that our x plus 2y is going to be related to. So there can't be any more than 400, no more than 400 people. No more than 400 people. If it is going to be no more than 400 people, then the number of people need to be less than or equal to 400. Now we need to graph these 2 equations. So we're starting with the green one. Subtract 3x from both sides. We'll have 5y greater than or equal to negative 3x plus 750. Divide everything by 5. And we will have y greater than or equal to negative 3/5 x plus 750 divided by 5. 150. And then graph this. This is written in slope-intercept form. So our intercept is 150. So we're going to go to 150 on our graph. If we look at our graph, we have 50, then 100. So that means that each line is going to represent 50 more. So this is 50, 100, 150. And that's where our y-intercept is for the green equation. And our slope in the green equation is negative 3/5x. So we're going to go down 3, 1, 2, 3, and to the right 5. 1, 2, 3, 4, 5. And there we will plot our point. Draw the line that connects our 2 points. And then we need to graph. This is y greater than or equal to, so that means we are going to be shading above the line. Now we need to do the blue problem. We need to get y by itself. So we're first going to subtract x from both sides. We will have 2y less than or equal to negative x plus 400. Divide everything by 2. We'll have y less than or equal to negative 1/2 x plus 200. Again, this is in slope-intercept form. So we have the intercept, which is 200. And we have the slope negative 1/2, and we will graph that on our graph. Our intercept is at 200. This is going by 50. So we have 50, 100, 150, 200. That's where our y-intercept is going to be. And then our slope is negative 1/2. So we're going to go down 1 and to the right 2. 1, 2, and that will give us our second point. And we can draw a line through those to get our graph. Oh, that wasn't very nice. But then we're going to shade. In our inequality, we have y less than or equal to. So less than or equal to, y is on the left side. We're going to shade below. So we're going to shade below the blue line. So this would be the solution. And where the green and the blue cross is our answer to this problem for the amount of tickets that they can be selling. the amount of couples and the amount of single people attending this dance. Any point that's inside this region will be covering the cost and meeting the requirements of the gym that can only hold 400 people. All right. For the rest of the period, you are to do your homework for tonight. And make sure you have your homework for tomorrow.